All right, guys. Well, in today's video, we're going to be looking at the final operation between polynomials, which is how to divide polynomials. If you remember, in the first section of this unit, we talked about adding and subtracting. The second section, we talked about multiplying, including how to multiply out polynomials where you're expanding a binomial, so using Pascal's triangle. Now we're ready to talk about division. There's actually going to be two methods that we'll talk about for division. There's kind of a more general method, which is what we're going to talk about today, which is long division. And then in an upcoming video, I'll cover the second part of division, which is all about synthetic division. So to begin with long division, it actually works best if you go back and remember how to do long division for integers or for numbers. So let's just remember kind of how that works. We're going to do a couple of warm-ups just to get the idea, and then we'll see how this applies to dividing polynomials. So for the first one, we're going to divide 1,597 by 6. So as a reminder for long division and how this works, what you're dividing by goes in front, and what you're dividing goes underneath. And then what you're going to try to do is you're going to try to multiply this 6 by some number to try to get as close to 15 as possible. In other words, multiplying it by 2 gives you 12, and that's the closest that you can get to 15 without it being too big. And then what you're going to do is subtract. So we're going to take 15 minus 12, and that's 3. Then you bring down your 9, and maybe if you had forgotten how to do this, it's starting to come back to you. Probably something you haven't seen since elementary school, and believe it or not, it's something we're going to use not only in Algebra 2, but in future classes as well. But now we're going to repeat the process. We're going to look for what number can I multiply 6 by to get as close to 39 as possible, and that's the number 6. And when you multiply 6 by 6, you get 36, so we are subtracting 36, and 39 minus 36 is 3. And then we repeat the process, so bring down your 7. And once again, we look for what number can I multiply 6 by to get as close to 37 as possible. That number, once again, is a 6. 6 multiplied by 6 is 36. We subtract to get a 1. Now, at this point, there's a bunch of different ways that we can think about this. What you're probably used to, kind of where you finish using this in elementary school, is you start to get into decimals. So you put a decimal place down, you start with zeros, start bringing those down, and then you start to look for patterns to see kind of where you can cut this off. We're actually not going to do that. We're actually going to go back to writing it another way, which, if you remember, is to write it as a remainder, which is 266 with a remainder of 1. In fact, we're going to go one step further. In our remainder, we're just going to place over what we were dividing by. In other words, we're going to put our remainder of 1 as being over 6. So we're going to end up with a mixed number. That's okay. In fact, with polynomials, we're going to end up with some mixed answers, but we're going to actually do that because we're going to keep the process the same. In other words, if you take 1,597 divided by 6, you get 266 and 1/6. Let's take a look at one more example of this just to make sure it all makes sense. We're going to set this one up pretty much the same way. So we're going to put 12 outside of our division symbol. The 7,349 goes underneath, and we'll go ahead and get started. Now this time, obviously, 12 does not go into 7, so we'll have to look at 73. The closest we're going to be able to get is to multiply by 6. 12 multiplied by 6 is 72. So we'll go ahead and subtract. We get 1, and bring down our next number, which is a 4. This one's pretty easy. How many times does 12 go into 14? Well, we can multiply it once. So 1 multiplied by 12 is 12. We subtract and bring down our next number. Finally, 12 and 29, you can multiply by 2. 12 multiplied by 2 is 24. We subtract and get a remainder of 5. And then remember, what we're going to do with that remainder is we're going to put it over what we were dividing by, which was 12. So our answer for this second division problem would be 612 and 5/12. In fact, with mixed numbers, we really should write them a little bit more carefully. Because really what we're saying when we say 266 and 1/6, that word and tells us that we're adding. In other words, this really should say 266 plus 1/6. And the same is true of B. Really, when we say 612 and 5/12, what we really should be writing is 612 plus 5/12. Now, we usually get pretty lackadaisical with that notation. We usually are okay writing it that way, but with polynomials, it'll be important to remember that you are adding your remainder onto the end. So without further ado, let's see how this is going to work for polynomials. So when we're dividing polynomials, first thing we have to have is that the polynomials must be in standard form. So think back to section 6.1, where we were looking at writing them in standard form. I should say 5.1, not 6.1. But we were writing them in standard form, so highest exponent down to lowest. In addition to that, we're going to need some placeholders. We're going to have to put in a 0 for any missing term. So if you're missing the quadratic term, put in a 0 for x squared. If you're missing the linear term, put a 0 for x. Last, if there's a remainder, it's going to go over your divisor in the final answer. So just like we did with our warm-up, we're going to put any of our remainders over their divisor. Okay, so taking a look at example 1, we're going to basically set this up the exact same way that we did our warm-up. So what we're dividing by, which is x plus 5, is going to go outside the division bar. And then underneath the division bar, we're going to put what we are dividing. So the x cubed plus 11x squared plus 39x plus 45. Now, this is a good point to check and make sure that you're not missing any terms. And we do go from 3 to 2 down to 1 to 0. So we are good as far as being in standard form. And we also are good as far as placeholders. Now also the x plus 5 is also in standard form and does not need any placeholders. Okay, so what we're looking to do is we want to try to multiply, and we're going to focus on this first term. We're going to try to get that x to match up with this x cubed. Or if you wanted to think about, what if you were to just take x cubed and divide by x? Well, that's x squared. So what we're going to do is we're going to put x squared on top of our division bar. Now, similar to what we would have done on our warm-up, if you really think about it, you're looking at 6 going into 15 2 times. So when you take 2 multiplied by 6, that's how we're coming up with this 12 right here. So what we're going to do is the same thing. We're going to take x squared, multiply it not just by x, but also by the 5. So remember to distribute. And we'll put that underneath what we're dividing by. In other words, if we take x squared, multiply by x, that's x to the third. And then x squared multiplied by 5 is 5x squared. Now, also, just like we did above, when you took 2 and multiplied by 6 and got 12, we were subtracting that 12 from the 15. So we're going to do the same thing down here, actually. We're going to subtract, actually, both of those two terms that we just found. What that's going to leave us with, obviously x cubed and minus x cubed are going to cancel. In fact, that should always be the case when we're dividing. And then we'll take 11x squared minus 5x squared, which is 6x squared. And if that part was confusing, at least the next part should kind of make sense based on what we did with our warm-up, which is that we're going to bring down our next term. And then we're going to repeat the process all over again. This time we're taking 6x squared and dividing it by x. So if we take 6x squared, divide by x, that's 6x. So we're going to put a positive 6x above our division bar. And now we're going to distribute that to both of our terms over here. So 6x multiplied by x is 6x squared. 6x multiplied by 5 is 30x. Now, once again, we're going to be subtracting, so we'll put minus signs for both. And once again, our first two terms are going to cancel. That should always be the case. But then 39 minus 30 is 9x. And then we'll bring down our last term. All right, so this time we're taking 9x, dividing it by x. And if we take 9x divided by x, that's just 9. So we'll put a positive 9 in our numerator. Not our numerator, our top of our fraction, or the top of our division bar. Then we'll go ahead and distribute the 9 just like we have the other two terms. So we'll take 9 multiplied by x is 9x. 9 multiplied by 5 is 45. Remember that we are subtracting. And in this case, what that means is that we end up with a remainder of 0. So it turns out that our final answer for number 1 is just this right here, x squared plus 6x plus 9. Okay, let's go ahead and take a look at another example. And let's take a look at number 2. So you've got x cubed minus 27 divided by x minus 3. So again, we're going to set this up kind of the same way. What we're dividing by goes in front of your division bar. And then what you're dividing goes underneath, so x cubed and minus 27. Now, if you're wondering why I wrote those so far apart, why didn't I just write them next to each other? It's because we're going to need to have some placeholders for this example. We are missing our quadratic term, so plus 0x squared. We're also missing our linear term, so plus 0x. But the rest of this is really still going to work the same. So we're going to take x cubed, divide by x, and that's going to be x squared. So we'll put that on top of our division bar. Go ahead and distribute that. So that would be x cubed minus 3x squared. We are subtracting, so remember to make your x cubed negative. Minus a negative means that the 3x squared is going to be positive. So when you're subtracting, really what you're going to do is change the sign of both of your terms. Then x cubed minus x cubed is 0, and 0 plus 3 is 3x squared. And then we'll bring down our next term. Even if it's a 0, we still bring it down. So now we're looking to divide 3x squared by x. So if we do that, we end up with 3x. So we'll put 3x over our division bar and go ahead and distribute it. So that would be 3x squared and a minus 9x. Remember that you're subtracting. So we're subtracting a 3x squared minus a negative 9x becomes plus 9x. So again, change both of those to be opposites and then go ahead and do the operation. So 3x squared minus 3x squared is 0. 0 plus 9 is 9x. And then we'll bring down our last term. So now we're taking 9x, dividing it by x. 9x divided by x is 9. So we'll put a plus 9 above. Distribute that so we get 9x minus 27. To subtract, change both of those to be opposites. 9x minus 9x is 0. Negative 27 plus 27 is 0. So that means our remainder is 0. So once again, actually, this is just going to be our final answer. Okay. So really, if you think about what's happening with a remainder 0, what that means, think about taking something like 24 and dividing by 4. Obviously, 24 divided by 4 is 6. With the remainder of 0, when we really don't write the remainder of 0 part, we just say that 24 divided by 4 is 6. And if you think about what that means, what that meant is that 4 is a factor of 24. If you extend that to polynomials now, what that means when we get 0 as our remainder, it means that x plus 5 is a factor of that original polynomial, x cubed plus 11x squared plus 39x plus 45. And so the same is true on number 2, that x minus 3 is a factor of the original polynomial. So obviously, if you get a remainder, then it's not a factor. So like on example for the warm-up part A right here, then you'd say that 6 is not a factor of 1,597. So we'll also see where we have a factor that's not, or something that's not a factor, In fact, I can't remember if that'll be on number 3 right here, number 4. So let's find out which one it is. So let's go ahead and set up number 3. We've got 12x squared plus 8x cubed plus 5 plus 6x divided by 2x plus 1. So what we're dividing by, we'll put in front, so 2x plus 1. And then what we're dividing goes underneath. Now don't start it with 12x squared. Just a reminder, we need to make sure that it's in standard form, meaning that we start with our highest exponent, which is actually 8x cubed. Then the next highest, which would be 12x squared. Then the next highest, which isn't 5, but 6x. And then our plus 5 at the end. Okay, once we've got that set up, we actually are good as far as placeholders go. So we can go to taking 8x cubed divided by 2x. Which 8x cubed divided by 2x is 4x squared. So we'll put the 4x squared above our division bar. Then we'll go ahead and multiply that through. So 4x squared multiplied by 2x is 8x cubed. 4x squared multiplied by 1 is 4x squared. We're subtracting, so make both of them minus. And then when we simplify that, 12 minus 4 is 8x squared. And we'll bring down our next term, which is the plus 6x. So now we're taking 8x squared, dividing that by 2x, which 8x squared divided by 2x is 4x. So we'll put a plus 4x above our division bar, distribute that through, so 4x multiplied by 2x is 8x, 4x multiplied by 1 is 4x, and then we're subtracting, so make both of them minus. And we'll get the 8x squared minus 8x squared is 0. 6x minus 4x is 2x. And then we'll bring down our plus 5. So you can probably already see that there's going to be a remainder. If not, we'll go ahead and show what that looks like. But we've got 2x that we're dividing by 2x, which is just 1. So we'll put a plus 1 up above. And then distribute that through, so 1 multiplied by 2x is 2x, 1 multiplied by 1 is 1. Again, remember that you are subtracting. 2x minus 2x is 0, 5 minus 1 is 4. So this time we did end up with a remainder. We round up with a remainder of 4. So the way that we're going to write that is we're going to put a plus 4 over whatever we were dividing by. So over 2x plus 1, just like we did in the warm-up. So then here would be your answer. You'd have 4x squared plus 4x plus 1 plus 4 over 2x plus 1. Now, what that means is that 2x plus 1 is not a factor of the polynomial we're dividing it by, which was the 8x cubed plus 12x squared plus 6x plus 5. Okay. Let's take a look at one last example, and that should be it for long division. So we've got x cubed plus 3x squared minus 13x minus 15. And this time we're dividing by something that's not linear. We're dividing by x squared minus 2x minus 3. So let's go ahead and set this one up. In fact, we're going to still set it up the same way. So what we're dividing by is going to go in front of our division bar. And then underneath our division bar is going to go our polynomial, x cubed plus 3x squared minus 13x minus 15. All right, we've got all of our placeholders. Everything's in standard form. So right now we just need to look at the x cubed, dividing it by x squared, and that's just x. So we'll put x on top of our division bar, and we'll go ahead and multiply it through. So x multiplied by x squared is x cubed. X multiplied by negative 2x is negative 2x squared. And x multiplied by negative 3 is negative 3x. Now we're subtracting, so go through and change all of your signs. So negative x cubed plus 2x squared and plus 3x. And then we'll add those together. So 3 plus 2x squared is 5x squared. Negative 13 plus 3 is negative 10x. And then we'll bring down our minus 15. So now we're taking the 5x squared, dividing it by x squared. And 5x squared divided by x squared is just 5. So we'll put a plus 5 in the top of our division bar, multiply it through. So 5 multiplied by x squared is 5x squared. 5 multiplied by negative 2x is negative 10x. And 5 multiplied by negative 3 is negative 15. Now again, you're subtracting, so go through and change all of your signs. Minus 5x squared plus 10x plus 15. And when you do that, actually everything is going to cancel and add to be 0. So we end up with no remainder on this problem, and our answer is just x plus 5. So once again, what that tells us is that what we were dividing by is a factor of the polynomial that we were dividing, and x plus 5 is what we get when we do that division. All right, guys, that is it for this section of notes so far. We will finish this section in a later video where we'll talk about synthetic division, which is a little bit more simplified approach to dividing. Works really well when you're dividing by a linear divisor. Until then, have a good rest of your day.